Welcome to Intro to Work, the physics perspective. So we are now going to talk about work as a physics concept. So the question is, what is work? So in physics, work refers to sort of the force times the distance that the force is applied. So to the force applied multiplied by the distance the force is applied. I apologize, I need to update my screen. Again, work is essentially force times distance. This is assuming that the force is constant for that entire distance. In terms of units, so for the units, we have our two systems. So in the metric system, force is measured in newtons, which we denote with an N. Distance is measured in meters, which we denote with an M. And work is measured in either Newton meters or joules. So again, work is measured in Newton meters better known as joules, which we denote with a capital J. In the imperial system, which is what we use for measurements in the US, force is measured in pounds, which we denote with lbs. Distance is measured in feet, which we denote with ft. And work is measured in foot-pounds, which we denote with ft lbs. Just a quick comment. So 1 joule is equal to the amount of work it required to apply 1 Newton of force for a distance of 1 meter. So 1 joule is the work performed to apply 1 Newton of force for 1 meter. Hence why joules are often referred to as Newton meters. Similarly, 1 foot-pound is the amount of work performed to apply 1 pound of force for 1 foot. So how does work relate to calculus? So in the real world, we don't apply the same amount of force all of the time, right? So in the real world, we don't always apply a constant force. So we can think of it as applying a full constant force for a very little amount of time, and then, or a small distance, and then applying a different constant force. So in reality, force changes, or force can change as we travel distance. So if we let f of x represent the force at a particular displacement. So if f of x is the force applied at displacement x, from the starting point, or distance x from the starting point, we can sort of approximate. We can approximate work by looking at little intervals of distance. And picking a representative force for each interval. So if our delta x is our width of our little distance, so is our interval distance, we pick xi in each interval. Then the work in interval I is going to be approximately the force applied at displacement xi times delta x. And overall work would simply be the sum of each of these f of xi times delta x. This looks exactly like what we're used to seeing for integrals. So if we letting delta x go to 0, or in other words, letting our number of intervals go to infinity, we get, so delta x go to 0, or our number of intervals go to infinity. Then we get that the overall work should be equal to the definite interval from a to b of f of x dx, where a and b are the sort of beginning and end points for our distance, and f of x is the force at displacement x from a. So where the object is being moved from A to B, and f of x is the force applied at position x. So we essentially get that work is just the integral of force, which makes sense since work comes from multiplying force times distance. So work is the integral of force with respect to distance or position. So in the next videos, we will look at some very specific cases where we can calculate work, standard cases to see in a calculus class.